So I did split this first section into 2 days. Chapter 6, while we're not covering this specifically today, Chapter 6 is all on inverse functions and relations, which inverse functions will be a little bit of review from Algebra 1, and then it's also on radical functions, so square root functions or even cube root, fourth root, fifth root. So we've already done some simplifying with radicals. We'll be doing more of that in this chapter. You'll just see more of that happening. So there are, like most things in Algebra 2, there are bits and pieces that are review, and then there's things that perhaps you haven't seen that weren't part of Algebra 1. A lot of what we're doing today, it's just arithmetic operations on functions, so you want to be able to add, subtract, multiply, and divide two functions. We did perform arithmetic operations with polynomials throughout Chapter 5, so this is just now applying it to any type of function, not just polynomials, so you still will see polynomials in this chapter. What is going to be new today, because the operations themselves are not new, adding, subtracting, multiplying, dividing functions. What's new is the notation that you're going to see, and you want to make sure you understand what all of that means. So if you look at the box that's on here, if you are asked, well, I guess what's in front, what I'll highlight here in yellow, this is typically how the problems are going to be given to. It'll say find, and then one of these four things that I just highlighted in yellow, that's how the problem would be given. You have to understand what that means. So the first one, this is just function notation. So this first one means f plus g of x. So if you were to say this or read it, so f plus g of x is how that first one would be said or read. And then you could just insert the different operations for the other ones, f minus g of x, f times g of x, and so on. So my main thing is I don't want you to think that this means you're adding f plus g and then multiplying by x. That's not what that means. It's f plus g of x. It's a function, so it means that you're adding f of x plus g of x. And these functions you would be given. So it does give an example here for each case. I'm just going to highlight this to show you what it means too. So you're given a function f of x, which is 2x, and you're given a second function g of x, which is negative x plus 5. So if you are asked to find f plus g of x, you just take f of x, which is 2x, and you add g of x, which is negative x plus 5, and you combine like terms. So it's more of, you've already simplified or evaluated problems like this, but they were given to you in this form. You have to get it into this form to know what you're simplifying. That's the new part for this lesson. So then f minus g of x, the next one for subtraction, same idea, but you're subtracting. So f minus g of x is f of x minus g of x. You can see in that example, they're taking 2x and subtracting negative x plus 5. And notice up here it didn't really matter. With subtraction, it does matter that this second polynomial or second function is in parentheses because you would have to distribute that minus sign when you're simplifying it. We talked about that in Chapter 5. F times g of x, so f of x times g of x, you're multiplying them. That is set up for you under the example, so that's distributing or perhaps FOIL, some combination of those. We've multiplied polynomials and functions before. And then f divided by g of x is f of x divided by g of x. There is a restriction though. It's called a restriction on the domain, if you want to make that note. Restriction on domain. And the domain, remember, is the x value. So when you have a fraction, you cannot divide by 0. Your denominator cannot be 0. So what this means is any x value that would make the denominator equal to 0 is then excluded from the domain. So they do give this example over here, f of x divided by g of x, and notice they're saying x cannot equal 5. And where they're getting this from is they're saying the denominator, the negative x plus 5, cannot equal 0, since the denominator can't equal 0. And if you solved this for x, You would subtract 5, divide by -1. You would then get x cannot equal 5. So that's how you figure out what the restriction is. But whenever you're dividing functions, you need to include any restrictions. And the directions will say that. The restrictions only occur for division. So also, I do want to point out in Chapter 5, with dividing polynomials, we did long division or synthetic division, and you do not need to do that in this chapter. You're not expected to do that. So when you're asked to divide f by g, you would just leave it like this. You wouldn't need to go through the long division or the synthetic division. So we're going to just go through some examples together, have you do some on your own, just kind of get back into things after finals. So in example 1, we're given two functions f and g, f of x, g of x, and it says find each function. So we're finding f plus g of x and f minus g of x. So it does say, and it will say in all the directions, indicate any restrictions in the domain or range. For addition and subtraction, there are no restrictions. So you don't even need to worry about that for these two. So for f plus g of x, now you don't need to write this every time. I'm just writing it so you understand where this is coming from. So again, from the table above, this means I'm taking the function f of x and I'm adding the function g of x. And I'm just going to insert what f and g are. So f of x is 3x squared plus 7x. You don't need to, but if you wanted to put parentheses around it, since that is f of x, you could. And then I'm adding g of x. I'll also put that in parentheses again for the addition. It's not really needed, but g of x is 2x squared minus x minus 1. So like I said before, you were given problems like this in Chapter 5. You had problems like this on your Chapter 5 test. To simplify this, you're just now having to set it up in this chapter on your own, knowing what that means. So now from here, just because this is addition, you're just combining like terms. So I have 3x squared plus 2x squared, so 5x squared. I have 7x plus negative x, so plus 6x. And then I have a minus 1. And that would be the function f plus g of x. So knowing how to set it up and then knowing how to simplify it. Any questions on part A? Okay. And then part B, f minus g of x. So this means f of x minus g of x. So here again, I'll put both in parentheses. So f of x is 3x squared plus 7x. And then I have minus. Now, f of x I didn't really need to write in parentheses, but when you're subtracting, you do need to make sure your second function, you do put it in parentheses, because I will need to make sure I'm subtracting that whole quantity or distribute the negative however you typically work through it, but everything needs to be subtracted. So I'm subtracting the quantity, 2x squared minus x minus 1. So I know, not that you have to do this, the way I typically work through it is I do distribute that negative to everything. So I have 3x squared plus 7x, and then when I distribute the negative to the 2x squared minus x minus 1, I get minus 2x squared plus x plus 1. And then I can combine my like terms. So some of you just subtract right away, which is fine. Just make sure you are subtracting everything. So I would end up having 3x squared minus 2x squared, so a 1x squared or just x squared, 7x plus x, so plus 8x, and then I have a plus 1. And that is f minus g of x. Any questions there? Okay, so then under example 2, this is just another example of addition and subtraction for functions, but I'd like you to do that on your own or in your groups. I'll give you a minute, I'll start walking around and answer questions you have, but we'll just check and make sure we all get this. One thing, careful when you look at part B for the subtraction, it's g minus f, not f minus g. So for subtraction, the order does matter. Make sure you're subtracting g minus f. All right, double check what you have. Just make sure. Sometimes I check kind of one person's, and then hopefully if you're sitting in a group, you're checking with each other too. But make sure I didn't miss something, like a small sign that you were missing. Make sure for g minus f of x, it's negative x squared minus 2x, or if you had negative 2x minus x squared, that's the same thing, that's fine. Any questions? Okay. And some of you are working ahead, which is fine. For example 3 and example 4, here you're given two different functions. Again, you're finding each function. When it says indicate any restrictions in the domain or range, the division in part B will have a restriction in the domain, and I'll show you how to find that. But for A, so we have f times g of x. This just means f of x times g of x. And you've already worked with multiplying functions, so if I set this up here, you do want parentheses around both because they're being multiplied. So f of x is the quantity 3x squared minus 2x plus 1 times g of x is the quantity x minus 4. I know some of you, with your multiplication, when you saw a problem like this in Chapter 5, if you switched the order of these, that's fine. The order for multiplication doesn't matter. Your answer would still be the same as long as you're distributing correctly. So if you wanted the x minus 4 in front, f times g, g times f, they're the same thing. So that wouldn't matter. Otherwise, you're just multiplying using that variation of the distributive property. So I'm going to take everything in that first polynomial and distribute it to the x minus 4. So I'm going to take 3x squared and distribute it to x minus 4. So I would get 3x squared times x is 3x cubed. So make sure when you add variables that are the same, you add their exponents. or multiply variables that are the same, you add their exponents. 3x squared times a negative 4 is minus 12x squared. And then distribute the minus 2x to both. So negative 2x times x is minus 2x squared. Negative 2x times negative 4 is plus 8x. And then distribute the 1 to both. So 1 times x is plus x. 1 times negative 4 is minus 4. And then just combine your like terms. And if you multiplied this differently, just make sure you're still getting the same thing in the end. So I have 3x cubed. I have a negative 12x squared minus 2x squared, so minus 14x squared. And 8x plus x, so plus 9x, and then minus 4. And that's f times g of x. Any questions there? I know there's different ways or different methods out there for multiplying, and you can use what you've used before. Just it's the setting up part that's new. And then for the division, the f divided by g of x. So this means I'm taking f of x, dividing it by g of x. And again, you have the restriction that the denominator, which in this case is g of x, cannot be 0. So that's kind of the formula for what we're trying to find. So f of x divided by g of x, meaning I need f of x on the top of my fraction here. So I have 3x squared minus 2x plus 1 is divided by g of x, which is x minus 4. And as I said in chapter 5, you learn long division, synthetic division, and you do not need to do either of those. You would leave your answer just like this. Also, don't start canceling things out. This is going to be more in chapter 8 where we learn how to further simplify expressions like this. You can only cancel things out if they are factors, not just terms. So for example, and maybe you're thinking this, and if you are at this point, it's okay. I'm just telling you to not do it. Some students might look at this and say, oh, here's an x, I'm going to cancel these out. You cannot do that. That does not work. So just leave it like this. You're done with the division part. This is part of your answer. But then you need to know what the restriction on the domain is. So how to find that is you take your denominator, always your denominator, or this is how I do it. And I'm going to say x minus 4 cannot equal 0. And then you solve that equation using whatever method you need to for x. So here to solve for x, I would just add 4 to each side. So this means x cannot equal 4. That is the restriction on my domain. So my answer, this is f divided by g of x, the function. The restriction on the domain is x cannot be 4. If the x value is 4, the denominator is 0, and that's undefined. So this whole thing would be the answer. Division is the only time you have to worry about that. So for example 4, there's another multiplication and another division. Careful with this division. It's g divided by f. So division, that order matters. So I want you to work through these. Make sure for the division you're finding your restriction. I'll give you a minute before I start walking around. Let me know if there's questions. We'll see if you'll get the same answers. Yes, yep, do both A and B.
Or do you have to do the same? Or you do like both?
It's just, yeah, the denominator can't be 0.
Okay, so it's only whether it's 2 or all.
Right, yeah. And then you just have to figure out, so like this is a quadratic, so you'd be solving a quadratic equation. So to figure out what x can't be, so you'd have to think about what methods you have to solve quadratic equations. Okay. But yeah, it's always the denominator.
You have to put this in the
Yes. There's a formula on the front board behind me that might help you with part B. Just a hint. All right, I know some of you still might be finishing up, so you can look up here when you're done just to double check. Make sure, again, I didn't miss anything, or some of you may not have been quite done, so I may not have checked this answer fully. I kind of wanted to see if you were on the right track for how to get your restrictions for Part B. So make sure for Part B, when you answer a division problem, you're giving the actual quotient, the function itself, and then you're giving the restrictions with it. So it's not two separate answers, it's all in one. This is the quotient as long as x doesn't equal those values. So again, you still don't have to memorize the quadratic formula. I think at some point you'll probably have used it enough that you should just know it anyway. I'll always provide it to you. You just have to know when to use it, when you need to use it. Okay, so I'm going to pass out your assignment. Your assignment is a worksheet, and we have 13 minutes left of class, so you have time to work. So I know I'm still doing homework quiz. I'm not actually grading this. You have time in class. Make sure you're using it to work on the practice. You do have a homework quiz on Thursday that covers 6.1 and 6.2. So anything from this assignment could be on that homework quiz. Make sure you understand it. Even if you feel super confident after the lesson today, it's still good to practice and make sure that you do understand it.